Topic we are going to learn about the motion of a particle in one dimension. For that we have to understand what is meant by motion in one dimension. So when the position of an object changes on a straight line, that is motion of object along the straight line is called motion in one dimension. And motion. If the position of the object does not changes with respect to its surrounding, it is said to be at rest. On the other hand, an object is said to be in motion if its position changes with respect to its surrounding in a given time. For example, a person sitting in his house is at rest with respect to Earth but is in motion with respect to the other planet. One more example is if two cars are going side by side with the same speed. So with respect to each other, they are in the state of rest. But with respect to the trees and the persons on the road, they are in the state of motion. That means motion and the rest are relative quantities and cannot be defined without specifying the observer's frames of reference. Position and the path length. Path length is the total distance covered by the particle. In figure 1, we observe the particle initially at point A and after some time it reaches the point B. So the total path length covered by the particle is 4 cm. But in figure 2, initially the particle at position B, it reaches at point C and finally come to the point A. So that means the particle covered the distance BC and then CA. So total path length distance is given as BC plus CA is equals to 14 cm. The motion of the object along a straight line is also known as rectilinear motion. Let us discuss about displacement. It is useful to define another quantity, displacement, as the change in position. Let x1 and x2 be the position of an object at a time t1 and t2. Then its displacement denoted by delta x. In time delta t is equals to t2 minus t1 is given by the difference between the final and initial position. That is delta x is equals to x2 minus x1. Here delta represents the change of that quantity. x2 is the final position and x1 is the initial position. In the given figure, we observe a girl is moving from point A to B and covered a distance 30 meters. Similarly, the boy is moving this point A to B but he covered the distance 16 meters. That means the girl covered a longer path but the boy covered a shortest path. The straight line distance or the shortest distance covered by the particle between the initial and the final position of the particle is known as displacement. There are three types of displacement: positive displacement, negative displacement and zero displacement. For the positive displacement, consider the particle is initially at point A and after some time it reaches the point B. So in this figure, for the positive displacement, initial value is 0 but the final value is B. So the displacement is calculated as final value minus initial value, that is 4 minus 0 is equals to 4 cm. For the negative displacement, consider the particle moves from B to A. In this case, the initial value is 4 but the final value is 0. That means the displacement calculated as 0 minus 4 is equals to minus 4 cm. This is the negative displacement. For zero displacement, consider the particle moves from A to B and then come back to the point A. So, in that case, the initial value and the final value is 0. Now consider one example. A cyclist is moving along the arc of hemispherical surface of radius 20 meters. As shown in this figure, if it starts moving from point A and stop at point B, then find out the distance covered and the displacement of the cyclist. If the cyclist starts from point A and reaches B along the arc of the given hemispherical surface, then the distance covered by the cyclist is given by the half of the circumference of the given circle. Therefore, distance is equals to half of 2 pi r. 2 pi r is the formula for the circumference of the circle. Now, we know that the pi value is 3.14 and the r value which is given in that example is 20 meters. After putting all this value, we get distance is equals to 62.831 meter. Now to find displacement, As we earlier learned that its formula is final position value minus initial position value. In that example, the cyclist's initial position is point A, but its final position is B. That is nothing but the diameter of that hemispherical surface. And if we know the value of radius, we can easily calculate the diameter of that value. So it is 40 meter. This is also the shortest distance covered by the cyclist. Now let's come to the highlight of that topic. An object is said to be in motion if its position changes with respect to its surrounding in a given time. Motion of a particle in one-dimensional means motion along the line or in the one particular direction. Distance is the total path length covered by a moving particle in given interval of time. Displacement has direction and can be represented by using vector notation. Displacement gives the shortest distance between 2 points, and the magnitude of displacement can be positive, negative or zero. So this is all regarding the basic terms of this topic, that is rest, motion, path length and displacement. In the next video, we will discuss about average speed and average velocity.